Okay. Hello and welcome to the Business and Studio Spotlight stage. I'm Lexia Tomlinson and I'll be your compere. Our next speaker today is Brendan Walker from BBC Coast, and he'll be talking to you about how you can build your own motion simulator.
Hi, thank you for the introduction. Great to be here today. As I said, we're going to talk to you about going Loco. Loco is a motion simulator which has been built by Middlesex University, and you can try it out. It's only about 50 metres over there in Future Skills on Hall 18. So go over there after you've seen the story behind it. So my role, actually, is as a thrill engineer. That's my job title. And what I do is I build experimental rides. I also work for people like Alton Towers and Thorpe Park. Has anybody been on 13 at Alton Towers? Yes. So that drop feature in 13, that's the kind of thing that they'll ask me to come in and create for them. They wanted to know how far in the dark do you have to drop somebody for them to be scared. But if you drop them a bit too far, you're wasting your money. I think it turned out to be something like 4.2 meters. But that's the kind of work I get involved in. But I was asked 2 years ago by Thorpe Park if I would create something for their hotel. So it wasn't a ride for the park, but they were making a hotel and they wanted to create a new, unique experience for one of their bedrooms. So I kind of got interested in the idea of sleep, because that's what you do most of the time in a bedroom. Could I do something with sleeping? And I knew this thing. I'd heard, whilst I was at university, that if you put somebody's hand in a bucket of cold water when they're asleep in bed, they might wee themselves. Now, this is like a popular myth. You can try it out with your friends, but there is an element of truth in this, that actually, when we dream and you go into REM deep sleep, you can start to incorporate things from the real world into your dreams. So light, sound, smells and taste even, and motion. So like that idea that, you know, if you're sleeping and your mum calls you to go down for breakfast and you sort of hear this voice in the middle of your dream, that's exactly the kind of thing I'm interested in. And I thought I could do something with that, create a new ride with those kind of ideas. So I found this device which monitors people's brains as they're sleeping, and when they go into REM sleep, so when their eyes start twitching and looking around, that's when you're dreaming. And this device could actually detect that moment when you're dreaming. And I thought, if I know when you're dreaming, then I can start to do stuff to you. The kind of thing I wanted to do was this: take an ordinary bed, turn it into a motion simulator, and get it to mimic the ride you've been on during the day. So I took this idea and I started talking to, and the idea was, when you're on the bed, you could select any one of the rides you'd been on. So you've just been on Swarm, if you'd been on Soar, you could select that before you went to bed at night, and as you went into REM sleep, the bed would start to move very subtly, not very severe, not enough to wake you up, but just enough to start your brain to remember the ride you've been on. And so for free, you would get to ride those roller coasters again in your sleep. So this was the idea. This was my engineering drawing that I was showing people, saying, well, let's take a bed, put some linear actuators on the corners of the bed to make it tilt and move. We'd record the motion from the rides, and we'd create this installation for the bedrooms. Now, unfortunately, Thorpe Park didn't like the idea. But I went to Middlesex University, where I'm a professor, and started talking to them about the idea of creating a motion simulator. And they got quite excited because Festo, who are also here at World Skills, fantastic robotics company, had developed this motion simulator themselves. It uses these things, these air actuator muscles. And they're pretty cool because if you put air into them, change the pressure, you can control them to within 1 millimeter of position. And because there are 6 of them, so this arrangement's called a Stewart platform, it's like a cradle of these air muscles, you can control the position of the chair to a very fine degree. And so Middlesex said, well, let's make our own. Let's make it so ridiculously simple that anybody can build their own. And let's make it so it's about 25% of the cost of any other motion simulator that's available on the market. So this is what we were aiming towards, working with Festo. And so now we have plans that you, if you wanted to, you can go home, you can get your schools to invest in making one of these themselves, because we have plans, and I'll give you the website at the end, but you can go and make your own using workshop skills that you've got at your very own secondary schools. Now, the cool thing about a motion simulator, the way it works, is that it plays on the inner ear, our sense of knowing whether we're being tilted, whether we're moving around. So the inner ear, these inner ear canals have got tiny hairs, and they can detect when you're moving around, a little bit like a Nintendo Wii controller, that you can sort of move it around, move it backwards and forwards. So you've got 6 degrees of motion. You've got rotation about each axis, X, Y, and Z. You've also got movement about all these axes. And that's exactly what this motion simulator can do. So this is simulation software. It's called VREP. And it actually shows us exactly the kind of movements we can get with our motion platform, and the kind of G-forces and the kind of extremes of motion we can play with when we start to create new rides using the motion platform. And so now, earlier this year, we released the very first version of this seat. It's been made and given to Tottenham UTC, University Training College, and working with Middlesex University and Festo, we're now going to start building more of these platforms. So this is the first. So the one you see over here is the very first one. We're going to start creating more, working with secondary schools to build their own, and for them to start working out what they're going to make with their own platforms. But I'll tell you about the first thing we ever made with our platform. So my role as a thrill engineer isn't just about creating rides. It's also about understanding what happens to people when they're on rides. So I monitor people's bodies using medical monitoring equipment to look at heart rate, to look at sweat levels, to look at what's happening inside people's brains. I've done stuff with Blue Peter. In fact, this is probably the first time I appeared on television, conducting experiments on Blue Peter presenters as they went around the UK trying to work out which was the most thrilling theme park ride in the UK. But earlier this year, I started to become interested in the brain, how to monitor what's going on inside somebody's brain. And somebody at a horror film festival said to me, while somebody's watching a horror film, what's happening in there? And I said, well, I could get this brain monitoring device, I could get the data, and I actually made this jelly brain which lit up, which showed exactly what was happening inside my brain as I watched a horror film. And we used this data, we managed to stream it over the internet, and so we could create these visualizations that were appearing on computer screens around the UK. In fact, even around the world, people could watch this brain live as it happened. So where does all this link with the chair? Well, I was asked by this company called Nesta to build a new ride for a festival. This was looking at the future of entertainment. And I said, well, how about we take the brain? If we know what's happening inside the brain, maybe we could get it to control a motion simulator. The motion simulator is going to be doing exactly what the brain's thinking. And so we created Neurosis, which was the world's first brain-controlled thrill ride. And this actually drove what we were developing the chair to do. Neurosis was almost like a cathedral to brain monitoring. The rider would sit at the top with their brains being monitored. Their data would create this abstract tunnel, this world that they flew through, and an audience of up to 200 people would watch this whole light and sound show. The lights and the music was all driven by people's brain data. The movement on the chair was controlled by their brain data. And this is the kind of system diagram that I draw. So I was trained as an engineer, but often I usually get my felt tips out, and this is about as complicated as my system diagrams get. This actually shows the brain monitoring, the controlling the chair, the music generation. I make models. So this is the kind of way I work as well. I still use plasticine, I still use sticks and balls when I'm creating my rides in Google SketchUp. And we also worked with a sound engineer to create the music for the ride. So this music is exactly generated from somebody's brain data. And of course, there's the whole sound show and light show that goes along with this as well. So working with lighting designers, lighting engineers to create the light show that goes alongside the motion platform. And finally, this was some of the images taken from working with a gaming designer, looking at the narrative of this story, because actually the tunnel that you flew through when you were riding Neurosis was all heavily scripted. You'd start out at the beginning, fly through, tumbling through a tunnel, and at the very end you would get squashed between two planets. But I'll actually show you a little clip of how Neurosis works. So the chair you see here at the centre of the ride is exactly the same chair that you can go and try over there.
Switching to auto control. Clear your mind.
So the point is that the motion platform came out of a creative idea that really responded to the entertainment industry. You know, working with a team of technologists and engineers, we've built this motion platform which is now incredibly flexible and is cheap enough and easy enough to make that secondary school students and teachers can go away and make their own. The control system has been created, so the software you need to run it is also freely available. So if you go to this website, you can have a look at the plans to download to build your own. The software will become available to control it. Basically, anybody can make it. And the challenge to everybody here is, if you can make your own motion platform, what would you do with it? I mean, it's no longer difficult to make one, so now you can think about things creatively and think of your own rides of the future. The ride you can try here at Future Skills, just over there, about 100 meters away, is a roller coaster simulator. So you can have a go on that and just start to think about what you might do with it if you got your hands on that kind of equipment. Okay, any questions, please?
Have you thought about using this system for training people? So, say there's complex manoeuvres for, I don't know, handbrake turns or whatever.
Yeah.
So you could have the inputs from all the controls in whatever system. So you could actually practice and practice and practice. So when it comes to doing it, you're a lot safer.
There is some work that's been done at the University of Nottingham working with Formula One racing drivers. So the question was, could this be used to train people in probably complex situations and possibly where the risks are much lower doing it in a simulator? Yeah, possibly. So.
The other thing is I do paragliding aerobatics, so you only get about 2 minutes for 4 hours walk up a mountain. So you could practice a lot doing it on something like this and then move on to doing it for real when you've got the 4 hours to walk up a mountain.
So I think simulators like this have got many possibilities. You can either use them for computer gaming and for entertainment, or for driver training, for example. So we are working with Formula One racing car drivers to look at the psychology about how to drive cars. And actually, because when you do something like, for the first time, like acrobatics, your first instinct doing anything new as a human is panic and terror. And by actually training and getting familiar to the sensations, you can actually start to combat that panic and terror so that you can actually function properly as a human. So these kind of motion simulators would be superb for that kind of application. And also, motion simulators, you know, if you're training a British Airways pilot, those kind of motion simulators cost tens of millions of pounds to build. This one costs £10,000. So if you're looking for simulators for activities that don't have the kind of budgets that civil aviation has, then you can make your own and start training using this. Any other questions, please? Good.
Thank you very much, Brendan.
Thank you.